Hi everyone, welcome to the video number 2 of this series. And in today's video we will be going to learn about some of the very important concepts coming to Boolean algebra. So in our previous video that we have discussed about introduction, right, and we discussed a bit about the propositional language. Now in this video today we will discuss about what are the various types of connectives, or you can also call them operators. Operators are present, right? That's very nice topic. Like we are having or, and then we are having conditional, biconditional, and then we are having not. By the way, not is not a connective because it doesn't connect anything. It can be applied only on a single statement. I will discuss that also, right? Now before going into the connectives and operators and all these things, I just first wanted to tell you one thing, that the propositions, they can be classified into two categories. Okay, let's start with the propositions only. So we are having a proposition. Okay, the one is simple and the another one is compound. For example, if you are having a single statement, let's say I like ice cream. Okay, so you can use a single variable for that. For example, I can use a p for representing this, right? Now let's say if you are having a statement which is not single statement but it can have like more than one component onto it. For example, same statement, I will change a bit. I like ice cream and mango shake. You might be thinking I'm a foodie person, although I'm not that much. Okay, so I like ice cream and mango shake. Okay, so the point is that we can see here we are having two statements, and because of this it doesn't fall under the category of simple, but now it falls under the category of compound statements or compound propositions. We also call them components, right, as we are having multiple components. If you see this statement particularly, you can find something here which is and, A and D. Now we already know that and is one of our operator, like we use dot for that, or we can use this sign. So this is a sign which we are using for and. So these operators, they are helping us in order to connect multiple propositions. We can call them propositions, we can call them statements or sentences, all the words same thing. Now with the help of this particular thing, we can connect this one sentence with this another, right? So this we will use and we will see how to explore it. Now let's discuss about what are the operators which are possible, right? We can also call them connectives. So there are multiple connectives possible. In today's video we will see most of them. Also we will make their truth table, how it looks. Okay, with the help of truth table we can identify that how that particular proposition, how that particular connective will be going to operate, how it will work. It's very simple, right? Let's start with and. So we are having and, we are having or, we are having conditional, we are having biconditional, and we are having not. Okay, this is my favorite, so I'm giving 2 stars to it. All right, so I'm making a rectangle here. I will let you know why I'm making it. Well, these are the connectives, and here below that one you can see here not. This one is not a connective, okay, because it will not use as a connector between two or more statement, while it is using for negation, like to make it opposite. For example, I like ice cream. If it is P, so what is P not or P complement? I do not like ice cream, right? So it will not connect anything, rather it will be going to negate the statement. It will make it, if it is true it will make it false, if it is false then it will make it true. Okay, so you know something to discuss here. So and we also call it conjunctive. Okay, for and the sign is dot and the one is this one. It is represented by this sign, and the or is disjunctive, and with this plus it will be going to represent, and this one. Okay, now conditional, also called as implication. So the sign that is used in the textbook, the one is this and one is this one. This is also there, kind of a magnet. I don't know. Okay, now one is biconditional, so it is having this sign. Bi means two, so why not to make two arrows, right? And in one of the textbook I saw it's hamburger, I can type like 3 lines are there. So again the biconditional. Now for not, this sign is used and this bar is used. For example, let's say that variable is p, so we can write complement p or p bar or p and raised to the power like this, c for complement, something like that. So these are very much common for not. Okay, so yesterday I got a new specs, so I'm very happy about it. Okay, so now you know these are 1, 2, 3, 4. They are the connectives, and this one is particularly is not a connective. Okay, now like how they behave. For example, if you talk about and, so for and, like for example, you are having, let's say, two p and q. You are having two variables, or you know, two you can say them statements. So if you talk about and, so both statements must be true. Both statements must be true. So then it will be going to give you the true value. Okay. If you, let's say you are having maybe 3 statements, so all three must be true. Then only it can give you the true value here. Okay. But coming to or, it's different. If in or, like if one of the statement is true, or all the statements are true, if one of the statement is true at least, then it will be going to give you the true value. Now coming to conditional, I am making a truth table, but don't worry, I will just make it very fast because of maybe practice. Okay, but you don't worry about it. I will explain you in such a way that you know, I will explain you deeply, so that you know you will never have a problem with implication. I got to know about some of the students, they are having some of the conceptual issue with it, that how this is working. But believe me, you know, I will make it so simple that you will never feel like implication was that difficult. Like it's really simple. So I will come to this point and I will explain you with an analogy. Okay. Now we are having biconditional. For that, you know, if both are true, both are false, then only it will be going to give you true. So let's now move to the truth table and let's understand each of them. Okay, that was a bit of theory that I explained you, but now we move to the truth table, and after that we will learn about them more clearly, right? So I will start with and only. So the remaining one I am writing here, or I have to explain. Then I have to explain you the implication. Then I have to explain the biconditional. And then I have to explain the not. Alright, so this will be the agenda for the class now. Okay, so I will start with and. I am rubbing everything, just remaining that and. Okay, for example, let's say you are having 2 statements. So if the number of statements are n, so how many values are possible in the truth table? It is 2 to the power n, right? For example, the number of statements are 2. Let's say those 2 are nothing but p and q. Okay, so what is 2 to the power 2? The value of n is 2. What is 2 to the power 2? It is 4. So total 4 values are possible. How? Let's make a truth table. pq, see, 0 0, 0 1, 1 0, and then 1 1. Okay, so these values are possible. you can't have more values than that, than all these, because when the variables are 2, so only these values are possible. Okay, so if it is like, let's say if it is and is p dot q, or you can also write p and q, like this also you can write. So what is this? It's 0 dot 0 is 0, 0 dot 1 is 0, 1 dot 0 is 0, and 1 dot 1 is 1. Yeah, instead of saying dot, I will say and. 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. So as we discussed, right, so that both the values or all the values must be true, then only it will give you the true. And coming to logic gates, we represent this AND with like this sign. Right, it's a 2 input AND gate. Correct. So let's say you didn't have only 2 values. Let's say you are having PQR. PQR, you are having like 3 statements. Can you tell me that in the truth table how many values are possible if the statements are 3? PQR? Yes, correct. It's 2 power 3. What is 2 power 3? Some people say 6, like I have checked some of the notebooks, but believe me, it's 8. 2 into 2 into 2. Okay, so 2 to the 4, 4 to the 8. Okay, so total 8 values are possible. For example, I'm writing here PQR, and here I can have like 8 values. Okay, so 8 values are possible. So the number of statements or number of variables are there. If you will do with 2 to the power that particular number, for example 3 variables are there, so 2 to the power 3, so you will get all all the possible values in the truth table, right? So for AND, we know that it's a conjunctive, and in order to get a truth value, so all the statement must be true. If any of one of will be false, so it will give you the false value only. Okay, now let's move to the next one, which is OR. Alright, so OR, it's also called as we discussed, disjunction or disjunctive. Okay, it represented by plus, or it represented by like V. One thing that I want to share with you, when we write AND, okay, we write A, and coming to A, we make A like this, and I don't know, it's a coincidence or what, actually AND represent like this only. Okay, so you can represent if this is AND, so that is OR only.